Hello everyone, this is Chenyu Xu, and in this video, I will introduce my research process on the topic of the deceleration equation of Shenzhou 13 re-entry capsule using its main parachute. Before diving into the presentation, I want to declare that due to the secrecy of China's space industry, all the data I could get were collected from all corners of the internet and were incomplete or even wrong. Therefore, what this video wants to convey is the process of conducting a research and less emphasis on the result. Okay, now let's get started. The research significance. My research is important because of the lack of research in aeronautic and astronautic topics among the amateur scholars. And hopefully this research can give them a sense and inspire them to investigate on those areas. The method I use. There are two methods, the literature review and the programming. I firstly look at articles and collected data and information I need in the later details, and then I program. I used the Jupyter notebook to code and run, and finally I derived a table and a graph to verify the correctness of my data, my equation. So this is the basic equation I use. It is basically the Newton's second law, where mg is the downward weight of the capsule and the parachute, and Fd is the upward drag force delivered by the air. And this net force is equal to m multiplied by dv over dt, which is the acceleration. And this is the secondary equation where I put the Fd into the basic equation. My theoretical base. Okay, this graph shows the different stages of the deceleration. Like the first stage is the using of guide parachute, and 2 to 6 is the drag parachute, 7 to 14 is the main parachute, and at the stage of 11, the baseboard is ejected from the capsule. And then I divide my data into two categories, the variables and the constants. And I will go through them one by one later on. Now the first one, air resistance. This coefficient is called CDP, where P stands for the parachute. And as you can see, the drag parachute and the main parachute are rift for several seconds, and then it is opened fully. And basically, rift is saying that the opening of the parachute is limited, so that the parachute will not be broke by the huge drag force. So for the rift one, the reefing ratio is 9% for the main parachute. And from one article, this epsilon here means the reefing ratio, and the closest data we can have is 0.232, and that I know it deviates a lot, but that is the closest data we can have, so we'll take that one. Here, the CDI means the coefficient of air resistance, and for that parachute, it is 2.085, and for approximation, we take 2.1. And then for the fully open parachute, from this graph, I can say that the shape of our parachute is between the working condition 2 and 3, so we'll take 1.2. So here comes the mass. And from one articles, I can get that the first time the parachute is opened, the guide parachute is opened, the weight of the return capsule is about 3,400 kilograms, and when it lands, like all those baseboards and main parachute are ejected, its weight is about 3,000 kilograms. So after all those complicated deduction, I can get the mass of the baseboard is about 307 kilograms. because we know the main parachute's weight is about 90 kilograms. This is from one official article. And then from one NASA's essay, we looked at the air density rho as a function of h, the height from the ground to the parachute. And it looks like this. Okay, so after all those variables, it comes the constants. First, the nominal area of the parachute, as we looked at the table, is 1,200 meters squared. And the radius of Earth is about 6,300 kilometers. And the mass is about 5.0972 multiplied by 10 to the 24th power kilograms. And the coefficient of air resistance of the capsule rather than the parachute is about 0.42, and this data was derived from the coefficient of a hemisphere. Like this graph shows how the baseboard of that return capsule looks like, so we will take that of a hemisphere. And then the nominal area of the capsule is about 4.8 meter squared. Now it turns to the practice. Here, practice, basically we used Python to write on Jupyter Notebook to code. So the first thing we use is the if statement. It claims the change of coefficient of air resistance and the mass at time equals 8 and time equals 192 seconds. And so there are 3 stages, basically. And then from the secondary equation, we have to put all those variables and constants into it. So we get something look like this. And then we import NumPy and SciPy and Matplot, which we use to plot the graph. We get a table that look like this. And 2 graphs. The blue dotted line represent the velocity, and the red one represent the height as a function of time. I will evaluate those 2 results. Firstly, the height looks ridiculous, but actually, because we have limited data, and we didn't take the angle of return into account, so like that error is understandable. And then it comes the velocity. Well, there you can just see there is a sharp drop, and that is about an acceleration of 54 meter per second square. And according to Newton's second law, it undergoes a drag force of 200,000 newtons. And well, that seems a lot, but again, according to one article, it says the normal military parachute can stand 100k newtons, and that doesn't deviate from my result a lot. So about some discussion about my research. Firstly, there are shortcomings, as you can see. The equation is not intact. We failed to cover all the stages of the entry, like we didn't take the stage that we use the drag force into account. And secondly, the data we use are inaccurate. I know it, because a lot of those numbers are speculated and deduced, but that is just because of the secrecy of China's space program. I just can't get those data. But there are some merits of my research. Firstly, it is innovative. Because of the use of calculus, I solved the differential equation, and I learned a lot from that process of learning to program. And secondly, compared to other news reports where they exaggerate the data, they don't report the real data, I collected more detailed data from the official websites like NASA or China Manned Space. And that is a huge improvement to the current research. So that is all for this video. Thank you all for listening to this presentation.